In the last video, we were talking about gases, aka utilities that industry can use, and some of the reasons that they might need to use them. So we talked about the concept that gases can be used in order to push materials from one location to the next, so it helps with the transfer process. We also talked about gases being used as blankets that will help protect those materials that we're trying to manufacture, that we're trying to bottle up and sell. And we also talked about gases being used through the sparging types of techniques that might be used in industry. So if we've got to bubble some type of feeder gas through, then this is one of the ways that we can do that, and that might actually be another purpose of a gas, aka utility. Compressed air systems we've mentioned with before, and we said, these compressed airs, it's not like your compressed air tanks that you have at your house maybe, especially if you're using power tools that require them. Some type of air gun, let's say. So compressed air systems can also be found in the pharma world, but we said that there's extra steps that got to be taken here, and the reason is because a lot of times these have to be very, very, quote, clean. So we've got to go through the steps of making sure they stay filtered, making sure no impurities are going to be in there, because all of that we are asking for trouble if we begin to use it. So compressed air systems, a couple of notes here about them. The first one says force air where it's needed. Okay, so I want you to think of again that nail gun. So that nail gun is hooked up to a hose, and that hose is hooked up to an air compressor. That is a compressed air system. So that compressed air system is going to deliver forced air to wherever you've got it hooked up, and that is to the nail gun, and eventually that compressed gas or compressed air is going to be used in order to push out a nail and go through a piece of wood. Same things happening in pharma, but we just got to be super clean. All right. Number two, compressor is going to pressurize the air. We've got to have some pressure build up, right? This makes sense, because if this is a tank with air, and if this is not under pressure, well, that little hose that's connected to my maybe nail gun, right? Okay, it's not going to work, or it's not going to work the best way possible. Because if I just let this kind of do its own thing and I don't build up pressure in it at all, there's no force, there's no oomph that can get it up out of there and send a nail through a piece of wood. All right, so this has to be compressed, and that means that the pressure has to be very high in these things. So compressors will pressurize that system, and it will build it up to a point that is safe, we hope, but that pressure is what's actually doing some of the work with whatever kind of attachment you have onto that compressed air tank. Number three, refrigeration will cheer the air, and that helps remove any of the impurities, and in this case, moisture mainly, that will happen here. So think of it as you going through a walk-in freezer. So compressed air could be coming from your lungs. Let's just pretend, right? So you're going to walk into a freezer and you're going to breathe out. And when you breathe out, that is air that you're breathing out. That is carbon dioxide that you are breathing out. But there's other things mixed with that carbon dioxide. It's not just carbon dioxide only, right? So you get this nice little foggy kind of air that comes from your mouth, and you can actually see that gas. Well, if I stay into that freezer long enough, and if that freezer is super, super cold, what will happen is that there's water around us all, right? So there's water and there's moisture everywhere. And all of that water and all that moisture will begin to freeze. So if it freezes, it will turn into a solid. And if it turns into a solid, it falls down to the bottom. So this is helping remove moisture that maybe cannot be involved in the process somewhere in the manufacturing line. So this is how I want you to think about it, how these refrigeration units are being used to make the air super cold, so that way it can remove some of the water content that might be present with these. Number four, we've got a fancy term. Ooh, Ooh, fancy. Desiccant. Desiccant. I desiccant. I desiccant do it. I desiccant do it, Tracy. I can't. All right, so desiccant is this idea that this is something material-wise that will also help absorb moisture. So if you're already looking at a trend here, you're seeing that water is not our friend in some cases, nor will it ever be. So here is another backup that we can use in the laboratory setting or in the manufacturing line that does a particular purpose, and that's absorbing moisture. So for instance, if you have bought something new recently, there could be a little bitty packet of beads on the inside, and those beads are going to be called silica beads, right? And you will see that on there. It will say silica gel or silica beads, and it will say do not eat. Okay, well, I hope you don't eat it, but they have to put that on there for people that do probably want to see, what does this taste like? I'm going to put it in my mouth. Well, that way you can't sue them because they told you don't eat it, please. Well, that silica is absorbing moisture. So if you can imagine, if you eat silica or if you eat desiccant, because that's what that is, then you can imagine what that's going to do to your mouth and down into your stomach and throughout your entire body or throughout your entire system. We just don't want that to happen. If it's absorbing moisture, think about what that's going to do. Well, okay, if it's absorbing moisture, then it's got to be put into those products for a reason. And that's because there could be a little bit of humidity or water vapor that kind of condenses on the inside of those materials, and they want it to stay dry. So you have encountered desiccants before. That is the proper term for that. But you just know it as like silica packs or those little bitty desiccant packs that are inside of those types of materials, whether it's luggage or backpacks or purses or whatever the case might be. Number 5, finally, after it goes through a couple of different steps, they will then store it, of course, until that very clean air is used. Now, a couple of things are going to happen here. What you're seeing over on the left is what they are referring to as a oil-free compressor. So the compressor is actually this piece right here. So the air, the raw air, is going to go in. And this is my compressor. It's the compressor if you bought it at Lowe's or Home Depot's. It is compressing the air, and compressing, I want you to think of pressure. So it is increasing the pressure here at this stage. So that way that can also be used to do a job or to perform a function. If that pressure is not built up, then it's not going to do anything at all. I don't see nails flying out of nail guns without air compressors connected to them, right? So that means the air that we're breathing in, it is regular pressure. That pressure cannot just randomly shoot nails out of nail guns. Could you imagine? Oh my God. Okay, so now that we kind of have an understanding of what a compressor is at home, that's what they look like maybe in industry or big manufacturing facilities. So much larger, right? Oh my God, it's bigger than me. So much larger than a regular compressor that you would see at your house. But that's just one representation of what these compressors might look like. These compressors have to go through a filter, right? And the filter is going to take any kind of large chunks out of it. And when I say large, I don't want you to think of like sand and dirt and leaves and sticks. That's not what we're talking about, because at this point it shouldn't have any of that in it anyway. But filters are going to be super, super tiny little pores. I mean, go back and take a look at the filtration types of lectures that we talked about together. So that filtration step is going to take out large molecules that should not be there. So for instance, things like organic types of compounds. Organic types of compounds should not be present. And those are sometimes very large, and those are sometimes harder to get out up until this point, and that filter system can actually take care of some of those for us, which is a good thing, right? So we often will get this preliminary filter that happens here. Next up, we talked about refrigeration, and refrigeration, now we know kind of an understanding of what's happening. This is our moisture kind of step, where it's removing a lot of that moisture, maybe not all of it, but the majority of it. So we get very dry, compressed air that will leave from this refrigeration unit. Next up, we go into our desiccant stage, And the desiccant stage is really just residual moisture that still might be present. So this is like a backup to the refrigeration step. So that desiccant is going to be used. That desiccant is going to get rid of any other traces of moisture that might be there. But desiccants also helped protect it so that way no more moisture can be gained. So from point A to point B, that transfer line might actually incorporate a little bit more moisture to this compressed air, and we don't want that. So desiccants help take care of that. It prevents the reabsorption of the moisture that might take place. Again, laboratories use desiccants all the time. We've got to keep materials dry, and if we keep these materials dry, we've got to do it in something called a desiccator, and the desiccator will have desiccant on the inside, and it kind of does the same thing here. All right. Next up, after the desiccant stage, it goes into a storage tank. And you can see one of those images of a storage tank here on the right-hand side in that picture. Often very large because we need a lot of it. We don't want to run out, and, it's got to be ready. These are not gas tanks that you would see maybe in our laboratory spaces. That is about as tall as I am and very, very slim. These are going to be much taller. These are going to be much wider, larger vessels to contain these gases that we will need to use for various purposes. Next up, after the storage tank, we don't want to take any risk because the storage tank, well, it could incorporate some contamination in here. We hope that it does not, but again, we've got to have a backup. So very often it will go through another series of filters here just to make sure that nothing is reaching to the end goal, because this is almost like right before we actually have to use it for whatever reason. So that filtration system, well, that shouldn't get dirty and filthy over a course of time quickly, because up to this point it should be fairly clean. But if it's not clean, that filtration system is there for a reason, and that's to help make sure that it is clean before it goes further on down the way. As you can imagine, these filters will have visual indicators on them most of the time, and those visual indicators will let you know, are those still working the proper way? Is it time to change those? Is it time to update them? Do I need to replace cartridges and so forth? So over a course of time, they do get spent. They do need to be replaced, and somebody's got to do that job. So there are often visual types of indicators that are on there for that reason. Other supplies, compressors, compressed air, that's great. But gases can actually be present in the manufacturing and in the laboratory settings in a number of different ways. Compressed air systems are just one of those, and we just talked about those. Number two are portable cylinders. So I want you to think of the picture here on the right-hand side, but just smaller. You can often kind of wheel them up with some type of dolly, put the gas tank on the dolly and wheel it out of the room, bring the new one in, transfer it from place to place, whatever the case might be. Those portable cylinders can also be used to supply gases. You can order these portable cylinder gas systems, what we call 5-9ers. So 99.999% pure. And very often analytical laboratories have to have this type of purity in order to do some of the testing that they've got to perform. And that's what we call that. That's kind of the lingo. 5-9er gas, please. So when I call air gas up on Carolina Beach Road here in Wilmington, I'm going to say, hey, listen, I need to order this gas. It's for an instrumentation piece that we have in our laboratory setting. I need 5-9ers, and they know exactly what I'm referring to with that. So 99.999% pure. Sometimes I don't need that purity level. However, sometimes I do. So there's different ranges of purities, as you can imagine, and the purer you go, the more expensive most of the time those tanks are going to be. Number three, we also have evaporator systems. And evaporator systems convert something that's maybe liquid into a gas form. So it evaporates. So I want you to think of maybe like boiling water on your stovetop. So I've got boiling water here. I'm getting ready to make spaghetti noodles. So I crank the heat up as fast as I can, and I'm waiting and I'm waiting and I'm waiting. And let's say I get a phone call and I go off and it's like a lecture video. 1 hour and a half later, I come back. Okay, well, here's the problem. If this is getting heated up and there's no lid on it, my stuff is evaporating. So my water is going to up in the air it goes, and I never get it back. And there's a chance that I'll go and my pot is maybe almost completely dry because I didn't turn the heat off before I stepped away from it. So my liquid is evaporating into a gas. These are evaporator systems. So what they're doing is that they're taking a gas that is in liquid form, like liquid nitrogen per se, and they are putting a little bit of heat maybe onto it, so that way it can promote this liquid to change into a gas. And that gas can then be harvested, and that gas can then be used for whatever reason that it needs to be used for. There are risks for everything, of course. When we work around gases, we're working around temperatures, we're working around pressures. So there's going to be a few things that we want to watch out for. Number one, they are compressed. So boom, it goes. So we don't want that to happen. So I want to make sure that I'm checking the regulators. I want to make sure that I'm checking the pressures on these gas tanks and the gas supply lines and where they are getting delivered. Because if the pressure builds up too much, then these things can go boom, and I don't want that to happen. My coworkers don't want me to do that either. Number two, gases, if they're not connected the proper way, of course, can lead to leaks. So in the manufacturing line or in the transfer lines or whatever the case might be, I could get a leak that's happening at some of these hoses or some of these connections or some of these fittings. There are ways that we can detect leaks, and most often is just like an electronic leak detector. So sometimes my ears can hear the psst that's going off, and sometimes my ears can't, but there is going to be a very slow leak that's coming from somewhere. So these leak detectors are going to be handheld devices, and I can pick them up and I can walk them out. It has a little wand. So this little wand of this leak detector is going to be connected to a little bitty magic Harry Potter wand, and I'll just go around and I kind of go around surfaces and valves and fittings and connectors, and if there is a flow of gas in some form or fashion, that little magic Harry Potter wand is going to be able to pick that up. And it's going to be beep, 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 beep. We got flow. We got something flowing out of here. And it will be able to detect it and tell me about it. I can find these leaks a little bit faster, especially if I can't hear them. So leaks are going to be a problem. And the reason is because these leaks can also go boom, all right? And we don't want that to happen either. But the leaks, and because we're using gases, and depending on the types of gases that we are using, can also make exposure. And exposure, stuff, folks, this could be poisonous, right? I don't want to go around these gases that can make me sick or that will make me go to the hospital because I'm breathing them in. I don't want that to happen. So leaks are important, not just simply because of boom, but also because of the exposure limits that's going to be associated with some of these when I work with them. Next up are pressures, and pressures create projectiles. Pew, 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 pew. Right? I don't want to start shooting stuff halfway across the room just simply because I build up too much pressure and stuff shot out of wherever that gas was located. So it could injure someone, it could injure me, and again, my coworkers would not be very happy if I slept on the job and I wasn't constantly monitoring the pressures of these systems that I'm responsible for. Number four, cylinders have to be secure. What that means is that these cylinders are very often going to be attached to the wall or some type of sturdy table or within a cage. That's how they need to be secure. So wall mounts is actually one example. A second option here is to connect it to some type of table that is secured, right? I don't want the gas tanks to outweigh the table. That doesn't make any sense, because the whole point of this is to keep the gas tanks sturdy, and that way they don't turn over and they don't damage anything. So that's kind of the table mount situation, but it still has to be maybe legs bolted to the floor or something like that. Number three, another way that we can secure them is through some type of cage. And these are cages and they're fairly large, right? Depending on how many tanks need to go on the inside. So the purpose of the cages is to put multiple tanks on the inside and then lock them up so that way they can't fall over. No one can get in there that's not supposed to be going in there, and they can be disconnected and safely removed and exchanged whenever that time comes around. So a couple of different options here to securing these tanks so that way they're not going to turn over and them themselves become projectiles where they're going to zoom across the room and knock out a wall or knock out a few people in the middle of it. Next up, number five, if they're not in use, make sure you put steel caps on the tanks if they are the portable types of tanks. There's actually a threaded piece up there at the very top. So here is the top of the tank. And at the top of the tank, there is often some type of stem with a little valve on it. And off to the side is going to be the hose of wherever it needs to go to. That valve is a multi-turn valve. Oh gosh, Tracy, I'm using my words. I learned what multi-turn valves are. Good for you. That's what we wanted. So that valve is going to be turn, and I can turn these gases on and I can turn these gases off. Well, if I'm not using them, and I'm not using them for long periods of time, it is always going to be better to turn these guys off. And then when I do turn it off, I'm going to take a cap. It's a metal cap that fits on top of this tank, and that will just make sure the valve does not get accidentally damaged. Because if the valve snaps off or if the valve gets damaged in some form or fashion, that's controlling the flow of gas out of those pressurized tanks. And I don't want that to happen. So that steel cap protects those things so that way I don't have to worry about it. All right. And then finally, number six, are you using the correct regulators? All right. Well, what's a regulator, Tracy? Okay. Well, a regulator is something that is attached onto the airline. And on the airline, we've got to be able to control the flow. So the multi-turn valve will turn the gas on, and yeah, it can kind of slowly let it leak, or it can just like let it burst out. It just really depends on what we want. But very often we need more control than that. So the regulator is giving us that control. It regulates the flow of gas. That's why we call it a regulator. So what's happening here is that there is a attachment most of the time to the valve piece. And I've just drawn it out here to the left just to separate it so that way you can see it a little bit better. And very often there's two different types of dials that will be on this regulator piece. And one of the dials will have like a meter and it will be up at a certain level. And this is like the fuel tank of your vehicle. So when you add gas into your car, the floater inside the gas tank makes that needle go up or float down when you're getting empty. And we need something on these tanks that tell us if they're full or if they're empty, or how much gas is left over at least. So one of the dials that I see on the regulator will be the fuel tank side, right? How much is actually present. The other one that I will see, because there's typically two, will actually be the flow piece. So this will help me control the flow of the gas in a more precise way that's leaving that tank. The flow, sometimes a common unit here is PSI, and PSI is pressure per square inch. So I dial it to that particular type of PSI that we need it at, and that is ensuring that the stuff that's coming out of this tank is actually flowing through and making its way where it needs to go with the right amount of pressure or the right amount of flow. So as my job as a technician, like all of these are things that we've got to keep in mind. However, in addition, if I want to recap, one, Pressure, 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 pressure. I'm going to talk like a real estate agent. Location, 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 location. Well, in this world with gases, it's pressure and pressure and pressure and pressure. That's what these are. So watch out for those pressures. Number two, you want to make sure that anything flammable stays away from these compressed gases. Think of a hair can spray, right? A spray hair can, oh my gosh, my words can't even come out of my mouth. Think about hairspray in a can, right? It is aerosol. It is under pressure. If you throw that can into a flame, pressure is going to build up and pressure is going to go boom, all right? And I don't want that to happen. That's why it says keep away from flame and hot objects. I mean, that's why that kind of warning is on there. So it's your job to help prevent these fires and explosions from happening. So if they do happen around gas tanks, folks, we got problems. We got issues because these things can turn into little bitty bombs if we're not careful. Number three, it says avoid suffocation. So keep in mind that if you do get leaks, and if you don't catch those leaks because you just don't smell it, you don't hear it, you've not brought out the leak detector wand, Harry Potter wand, right? So you can actually start displacing the oxygen that you need in order to breathe. And if that gas pushes that oxygen out, then you're going to begin to suffocate. And sometimes you might not even realize it. You might just kind of get weak-headed. You might get a little fainty, and then you'll pass out and you'll go into the floor, and you'll never know any different. So because of that, these areas will often use oxygen sensors. And if the oxygen goes below a certain level, then this is a warning. It's a sign that they can deliver to you to say, hey, something's up. Warning, 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 warning. You're going to suffocate if you don't do something about it, folks. So think of like your fire extinguishers and your carbon monoxide detectors at your house. We've got sensors that detect oxygen levels, and if it goes below a certain level, then there's an auditory warning and flashing lights very often that happen with these sensors. Number four, use caution, especially in low areas. So if you do get leaks, sometimes the gases have very low densities. So what that means is that if I put this into a big pot and I pour some gas in, well, really high densities will settle to the bottom. So high densities are going to go here. That means they just weigh a little bit more, even though density is not really kind of weight based. That's not really the proper definition, but that's kind of how I want you to think about them. They're a little bit heavier, and because they're heavier, they settle to the ground. It's like fog, right? Next up, lighter densities will settle on top. So I get a lighter density maybe up here, and that lighter density will float. Maybe that's at face level, maybe that's above my head, I don't know. But with these gases that are very dense, they will settle to the floor. So whenever you're working in low areas, on your hands, on your knees, whatever the case might be, keep that in mind. That's going to be an important issue, especially around gases. And number five, be cautious. Some gases have no odors. You can't see them. You can't detect them. You can't smell them. And they are invisible to you. So just because you don't feel anything's weird or smell anything weird, that doesn't mean that it's not there. So just be really careful. Keep in mind of your surroundings, and keep in mind the gases that are around you in these compressed tanks, because if they do leak, you need to be able to respond to that very quickly in the correct way. All right, so that's going to be it with gases. I think that's enough that we can say about that particular utility, because that's what this lecture blurb is all about, utilities. And in our next set of videos, we're going to talk about our other utility, which is going to be water. So what's happening with water? What are some of the different definitions with water, different qualities of water that we need to bring in to the picture? So in the next video, that's where we're going to pick up.